Okay. Mahmood? Gafar? Amjad? Sarah? No? Okay. Mo? Daniel? Sevi? Sabrina? Alfreda? Arya? Chidi? Young Pang? Amna? Yeah. And Mariam? No. Okay. Yeah. 5C. Do you think the answer's wrong? Yeah, because there might be questions in the next one. We should collect some up and do it in tutorial this week. Yeah. So just circle it then for later in the week then. Here you go, Mo. Thank you. Right. Okay, let's continue now. So we're looking at combinations now. So for these ones, we don't actually care about the order. So it doesn't matter to us what order something is in. Okay. So what are some examples of combinations? So what are the things where we don't care about the order? What are some examples? So this might be people on a team. List of people on a team. What else could we have? Shopping list, yeah. What else?
Class list.
Shopping and class list, yeah. The other famous one is a hand of cards. Don't care about the order in that. Anything else? They're kind of the main examples then. Okay, so let's have a look at a question to get started. Let's say you have a class of 30 students and you need to form a team of 5 from the 30. So this would be a typical kind of exam question. It's a possibility of 30, and you have to take 5 people out to make a team, whatever the team is. So obviously this one here is without replacement. You can't just pick the same person 5 times. You have to pick out 5 different people here. So can I scroll down a little bit? Yeah, I'll give you the formula in a moment, but I just want to see if you can figure out the answer, if you just have a minute to think about it. So you have 30 people and you want to form a group of 5. And you can actually use what we did in the last lesson as the idea to how you might work this out. No. I mean, it'd be great if I could make a team where it's just Young Pang, Young Pang, Young Pang, Young Pang, and the 5th person is Young Pang. But in real life, we can't do this.
It's not reducible, then it's just 30 divided by 5.
Oh, no.
What's the question?
It's how many ways, yes, is this possible? How many teams are there? Teams of 5? No. 720 maybe? That seems too big. What? Seems too big. You're sticking with 720? Okay. So look, you have to pick the first person for the team, right? So how many people can you pick for the first person? 30. And then the next one? And then 8. Now, it's not quite as big as this because you don't care about the order. You know, whatever person you picked first, you could have picked them last. So you can rearrange this list, and you don't care if you rearrange it. How many ways can you rearrange this list? How many ways can you rearrange 5 things? 5 factorial, good. So the answer is that over 5 factorial. And what's that? Is that what you did, Sabrina?
142506.
Ah, 142506 then. Yeah? You got 720. It's a little bit off. One four two five oh six, yeah? Yeah? How did I get that? I typed this in. No. 30 times 29 times 28 times 27 times 26. All over 5 factorial. Yeah? Oh yeah, don't worry, I'm getting to that, don't worry, yes. What was I saying? Oh yeah. There's about 142,000 different teams that you can make from your class of 30. Now, of course, you can't make all those teams at once, but that's not what I was saying. You were saying 30 divided by 6. Or 30 divided by 5 is 6. You can make 6 teams at once, but I'm just talking about how many different lists of, possibilities are there for a single team. Okay, can I continue with this one? So, if you look here, you can rewrite that, if you like, as 30 times 29 times 28. You can go all the way down to 1. But you don't want 25, 24, 23. So if I put 25, 24, etc. all the way down to 1, can you see that those guys will cancel up there? Yes. Leaving me with just 30 to 26 in the end. And I still need my 5 factorial. But 5 factorial, how do we, that was 30, 5 factorial there. Yeah. Now, I'm trying to make this equal to something that you've seen before. So do you remember you had this in semester 1, 30C5? So on the top you have 30 factorial. That's what we have here, isn't it? And then 5 factorial. That's what we have here. And then 30 minus 5, 25 factorial, which is what we have here. In other words, if you type in 30C5, you should get the same answer. And that's the quickest way to do it. So, a combination of n from a group of m can be done in MCN ways. So you can actually use this C function that we learned about in semester 1 to calculate the answer here. So I'll give you another one in a second.
So,
Go.
is there a way or room to combine two like 5 factorial and 25 factorial?
Say again?
Can you combine that in any way possible?
Which one?
Like 5 factorial and 25 factorial.
No, it stays separate. Okay, can I scroll down? No? Okay. Okay, can I scroll down? Yeah? Okay, so let's look at one using this, but a little bit harder now. So again, we'll keep it the same. There's 30 students in the class. At this time we'll just make it 22 male and, no sorry, I want to keep it a bit more even. 18 male and 12 female. Same deal again. I want to make a team of 5. A team of 5. However, let's say because of some equality law, for example, the team must have 2 females and 3 males on it. Like that. Okay. So, how many ways is this possible now? Again, I'll just give you a minute to think about it before I give you the answer. So, there should be less because you've put in more restrictions. That's what we learned in the last lesson. If you start putting in more restrictions, you get less. You know, start with a vowel, things like this. So I'll just give you a minute to try this.
We have 2 restrictions. It's just not combination.
What do you mean?
You're saying you have to have 3 males and you have to have 2 males,
Yeah.
2 females.
Yeah.
Or is it or and?
And. Yeah. Could be. Could be. Yeah, you mean like think about it as 2 separate problems. Yeah. Yep, exactly. Yeah, this is the way to be thinking about it. So it's like you're doing 2 selection problems. Yeah. Yeah, okay, I think some of you are getting the idea here. So, as you were saying, the best way to think about this is as 2 selection problems. First, you have to pick your 3 boys, and then you have to pick your 2 girls. So what we just learned, picking your 3 boys from a group of 18, that would be 18C3. And then picking your 2 girls from a group of 12 would be 12CT. And do we multiply or add? No, multiply. Yeah. Now the reason you're multiplying, it's a bit like you're combining. Okay, so I'll give you an example here. Like suppose that you had 4 choices for boys, okay? Guys, look up for a second. Let's just say you had 4 choices for boys. So you could have choice 1, choice 2, choice 3, choice 4. So it doesn't matter what the 4 choices are. Maybe choice 1 is David and Michael, and choice 2 is David and Barry, or whatever. You have 4 choices. And let's say for the girls, let's just say you have 2 choices. I'll just call them D1, D2 then, like that. So the number of choices I have is not 6, because I could have done C1 and D1. That's 1, isn't it? 2, 3, 4. Or I could have done 5, then 6, then 7. That's 8, isn't it? So it's not 4 plus 2. They combine as 4 times 2. Okay, so just be careful with that. They multiply here. So what do we get when we multiply this out? Still pretty big, is it? 5, 3, 8, 5, 6. Much less than before. Much less than before, but still pretty big. Yeah. Okay. I'll give you another one like this, and then one that's a little bit harder. Can I scroll down? Yeah. Okay.
What about the 3 plus 5?
What do you mean? There's 54,000 ways you can make a team of 5 where 2 of the members are girls, 3 are boys, from a class of 13 boys and 12 girls. 18 boys and 12 girls. Yeah? Okay, Amjad? What's confusing you? No? Okay. Can I scroll down? Yeah? I'll give you another one like this, okay? Okay, let's say you have 30 people again, and people are in 3 groups. 1, 2, 3. Let's say 3 ethnic minorities. 10 people from group A, 11 from group B, and 9 from group C. And you want to form a table, a league, some kind of group of 6 people. And you would like 2 representatives from each minority. So in your group of 6, you want 2 from each minority. So how many panels of 6 can you form? Where 2 must come from each ethnic minority, A, B, and C. That many? Yeah. Okay. Yeah? Okay, so what did you type in to get the answer? 10C2 times? Okay, good. Times. Okay. Right, now let's do a harder one. I can scroll down? Yeah? Yeah? Okay. Right, let's say I don't know. No, actually, maybe some of you don't. Do you know this game here, the lottery? Lotto. You pick numbers. And if you pick the right numbers, then you win a big jackpot. So the way it works is you have to choose 6 numbers from 1 to 47. So, 11. You might choose 11, 6. 2, you get the idea, 20, 41, for example, something like this. So you choose 6 numbers, and if these 6 numbers are the same 6 numbers that are drawn, then you win. Okay. So my first question then is, how many ways could you get 6 numbers here? So how many possible outcomes are there? How many choices do you actually have here? Would it? No, it wouldn't be 6 factorial, no. It is, isn't it? Because you have 47 numbers and you're choosing 6 then. Yeah, you don't care about the order. What's that? Is that like something like 2 million or something, or 3 million?
1 million.
Oh, that's not too bad. What is it? 10 million and 1 million are very different. 10.7 million about, is it? 10.7 million. So do you understand that if there's about 11 million possibilities, and each possibility is equally likely, then your chances of winning are 1 in 11 million. You understand? Because you have to correctly pick from a choice of 11 million possibilities.
Is it possible nobody hits?
Yeah, that would happen about, I don't know, maybe about half the time.
So nobody wins again.
Yeah, the jackpot gets added to next week's. It continues to accumulate then. Okay. Right, so you can get prizes for matching some of the numbers. Okay. I want you to calculate how many ways are there for you to match 2 numbers. So this is here, you match them all perfectly. Okay. Now maybe that's a little bit too hard. No, before we do that, I'll give you an easier one. That one's fine then. So you have 11 million ways to match this here. Can I scroll down? I can scroll down? Yeah? Okay. Let me give you another one. We'll go back to a simpler book example, maybe. Okay, so let's say you have 20 books from, I don't know, 20 maths books, 20 physics books,
Job.
10, what?
Job.
I know, okay. Right, and you want to choose 3 from here, take 3 out from here, 2 out from here, and 1 out from here. How many ways can that be done? You have 20 maths, 20 physics, and 10 geography books, and you choose 3 from the first, 2 from the second, and 1 from the last. How many ways can you do this?
2 million.
About 2 million, is it?
2.166.
Okay, 2 million then. Okay. So what did you type in? Yep. Yeah. Okay. Now, I'll go back to the Lotto one now that I think we've done a couple. So the next one I want you to do, can I scroll down? Okay, so it's the same thing. You choose 6 from 1 to 47. Okay. We've already done part 1. How many ways are there to get a 6 match? What did we say? Like, it was about like 11 million nearly, wasn't it? Okay, so the second one I want you to try, which is actually a good bit harder, is how many ways can you match exactly 2? So what I mean is you picked your numbers and only 2 of them are a match, not all 6, just 2 of them are a match. Now you really have to think about that one. So I'll give you a minute.
So the numbers you pick are matched to the most winning number.
Yeah, yeah, exactly. Could be.
I got 1.15 times 10 to the power 14. I don't know this was that correct.
10 to what?
10 to the power 14. It's more than the overall.
It can't be more than the previous answer.
It's more than
6,486.
That what you're saying is there's more ways to match 2 numbers than there are to match. No, not just. What is it?
6,486.
I think someone else had an answer. What did? 400,000 and 6,000. Okay. And 10 to the 14. Where we're covering a wide spectrum of possibilities.
I got 3 million.
You got 3 million. Okay. Nobody's got a negative answer yet. No, okay, well that's something anyways. there's minus 4 ways that this can be done. Okay, shall we have a look here? Yeah. This is a good way to visualize what's happening here. So you have what did I say, 47 numbers, isn't it?
Yes.
Yeah. And what happens is there's 6 numbers picked out here. 1, 2, 3, 4, 5, 6. And you pick out your 6 numbers. 1, 2, 3, 4, 5, 6. And you want 2 of your numbers that you picked to match 2 that was drawn. So, you're choosing 2, but only from a possibility of 6. Now you might think, oh, so I'm finished now. It's just, there were 6 winning numbers, and you want 2 of yours to be winning numbers, right? So it's just 6 choose 2. However, there's a little bit of a complication because you want the other numbers to be losing numbers. Because otherwise what you're doing is you're counting here possibilities where you've got 2 and maybe more. Okay? So you're not just picking 2 winners from a group of 6 winners. You're also picking 4 losers from a group of 41 losers.
Well, you don't have to be losers.
No, but that's why I emphasize the word here, exactly. So when I said I want exactly 2 winners, I want to know you pick 2 numbers that won, but that means the other 4 numbers are losers. So it's actually 6 choose 2, and then 41 choose 4. So if I multiply those 2 together,
Around 1.5 million.
I don't think anyone said that. That's about 1.5 million then.
That's 41C4.
41C4. You're choosing 4 losing numbers from the 41 losing numbers and 2 winning numbers from the 6 winning numbers. It's the exact same comparison of making the teams, you know, like choosing 3 men from the group of men and 2 women from the group of women. It's the same idea. It's just it's harder to think about it that way for this type of problem. What? Huh? You pick 2 numbers from the 6 winning numbers and 4 losers from the 41 losing numbers. Yeah? No? Continue? Yeah? I said it was a hard one, that's why I was waiting for you to do this one. Can I scroll down? Yeah? So you could actually now do something like this. What's the probability that you match 2? So remember what we said the definition of probability was. It's how many outcomes you want over how many total outcomes there are. In total, how many outcomes are there for this game? No, there are not 47 outcomes. About 11 million, about. And how many of those outcomes do you want? 1.5 million. So in total, what's that about? About, what percent would that be? Well, let's be a bit more precise. It wasn't 11, it was 10.7. Yeah, let's be a bit more precise. 1.5 over 10.7, what's that? 14%. Okay, so what you're saying is if you're playing this game, there's a 14% chance that you'll match 2 numbers. It doesn't sound too bad, does it? If there's a little prize for matching 2 numbers. I think it's like €2 or something. No, it might be like €2 and then it's €2 to play, so you've got a 14% chance of winning your money back. I think it's like maybe about 2 million.
Then last year, this American guy won like $1.6 billion.
Yeah, because I think the jackpot was continuing each week then. Did you write this one down now? Yeah? Okay. Let's do one more. Can I scroll down? Yeah? Okay, so let's have a look at a 52 deck of cards. And you draw 5 cards. So 5 hand. Okay, and I want the number of ways to get, let's see, 3 number cards and 2 picture cards. So by number card I mean an ace to a 10. And a picture card is jack, queen, king. So I want to know how many hands you can have where 3 of the cards are number and 2 of them are a picture. Okay? This is just like the example with making the teams, if you think about it like that. We'll check now. Right, well, what do we type in? What's the first thing?
43.
3 number cards. Yeah? How many number cards are there? 40. So it's 40C3 times, and there's 12C2. Okay, so how many does that work out to be? 4. Yep.
No, 652,000.
Yes.
Ah, come on. 600,000.
52. 080.
080. Okay. So about 650,000 ways to do this. Yeah? Is that one okay? It's okay?
Yeah.
Make sense? Okay. Let me give you. I'll give you another one. So that was number 1. How many ways can you get 4 red and 1 black? Try that one. Yeah. Yeah?
9,295.
Let's calculate. So what do I calculate? What do I type in? 26. 26C4. There's 26 red cards. Times C1. Okay, the last question we'll do. So how many ways are there? Same thing again, 52 cards, select 5, and you get a flush. What one's a flush?
Jack, King is.
No, that's a straight.
The same
The same what?
The same.
Yes, yeah. The same suit. Yeah. A flush means 5 cards which are all the same suit. So for example, 5 hearts or 5 diamonds or 5 clubs or 5 spades. That's what a flush is. Okay. Which one? Ace?
No, I was talking about the royal flush.
Because you were saying ace, king, queen, jack, and the
Ah, okay, yeah. But that's a straight as well, isn't it? Because you're going in order. and you're starting with a king.
You starting with
Ace.
You're starting with an ace, king, queen, jack,
10.
10, all of the same suit.
Yep.
Yeah. Is that the highest hand?
Yes.
Yeah.
So which one do you do? The one you just said?
No. Just 5 of the same suit. So 5 hearts, or 5 diamonds, or 5 spades, or 5 clubs. Yeah? Well, let's see. So what should I calculate first? Well, let's do 5 hearts. So what's the probability, or how many ways can you get 5 hearts? 5. How many ways can you get 5 diamonds? It's the same, isn't it? And then the next 2 are the same. So it's 13C5, 13C5. Now, how do these combine? Multiply or add? Add. Now, why not multiply? Because it's not one after the other. It's not like you get 5 hearts and then you get 5 diamonds. It's you get 5 hearts or you get 5 diamonds. So remember, the or is a plus then. So what does this work out to be? 5, 1, 4, 8. Times 4. Yeah. 5,000 ways.
Why is it 5 and 4?
Why is it what?
5.
Why is it what?
5. Oh, 5 parts.
Okay. Yeah. Yes, okay. By the way, Daniel, how many ways are there for the hand you listed? You're overthinking it. There's only 4 ways.
Yeah.
There's only 4. Because you can have, you said the first card was king, wasn't it?
Ace.
An ace, sorry, an ace. So you could have an ace with the hearts. Or it can start with ace with a spade. So, you have no choice on the other 4 cards, because for the royal straight flush, once you have the suit set, then the other cards they have to be what they are. Yeah. So there's actually only 4 possible ways, 4 hands that would give you that. So you can see why that's the highest hand, because there's 5,000 ways to get a flush, but only 4 ways to get a royal straight flush. So when you compare them, it's like this one is 100 times, like 100 times more common than that one. Okay, I'll let you try these. We can actually finish there, and you should definitely try some of these at home then, okay?